Okay, today we'll talk about the diode value to ground. Before checking the diode value here, we need to know that the PCB has 3 states. One is called open circuit, one is called short circuit, and the other is the normal circuit. Here the motherboard of the computer uses DC power. Then the direct current is also what we call DC. It is divided into positive pole and negative pole. Under normal circumstances, there is a resistance between the positive pole and the negative pole, which is called normal circuit. Then the positive pole and the negative pole are directly connected, which is called a short circuit. Then the open circuit is bad, the short circuit is also bad, and only connected circuit is low belongs to the normal state. So when we are repairing it, how we judge its state? At this time, we will check the diode value and use a multimeter in our hand to measure. At this time, our multimeter needs to be in the diode gear. Use the 2 pins of the multimeter. Connect the red pin to the negative pole of the motherboard, that is, the ground wire doesn't move. The negative pole refers to the screw hole on the motherboard, or the iron sheath of the interface, or one end of the capacitor. Then the positive pole is positive pole except for the negative pole. This is a traditional method. In the practical maintenance, we try to open the bin mat to see. When we are repairing mat, the bin mat is most standardized. Open the bin map. How many colors are there general on the bin map? Generally speaking, red means positive pole, and gray represents a negative pole. This kind of standard separation method. Then when measuring, the red multimeter pan is placed on the negative pole of the motherboard, and the negative pole can be used. And our black pan can only be placed on the positive pole. At this time, we look at the diode value. If the multimeter will display several states, we call OL open circuit. If the multimeter reaches the diode gear, if the OL can be measured, it is an open circuit. If the multimeter makes a beep sound and the value is 0.00, we can call it short circuit. If the value is several hundred, it is normal circuit, usually around 300 to 800. After getting the motherboard, I can show the method of checking the diode value. Then short circuit and open circuit are both bad. Only connecting circuit to load is normal. This is diode value to the ground. Then let's take a physical demonstration. Okay, let's take a look at the diode value. This is a main circuit board. When we check the diode value, the multimeter will switch to this gear and switch to the diode gear. Don't connect the two multimeter pan upside down. Connect the red pan to the earphone port. Connect the black multimeter pan reversely, connect it to the COM port. We don't use these two ports, rarely use them. When we measure this motherboard, these inductors had to be measured against the diode value in actual maintenance. Screws all include the iron sheet of this interface, which are all negative pole. At this time, when we are checking the inductor value, let's take a look at the negative pole. The iron sheet of the interface, including the screw holes, are negative pole. Then these inductors are all in positive pole circuit. So if I want to measure its value, we put the red pan on any negative pole and don't move. Then the black multimeter pan is placed on the inductors. You can see that its value has several hundred. You see this belongs to a normal state at this time. The value should be 472 ohm. If OL is displayed, it is an open circuit. If it displays 00, it is short circuit. This is called inductor value to ground. If I measure this inductor to check it again, 139, this also belongs to normal circuit. Look at the value of these capacitors. We can all measure them out. Under normal circuit systems, they are normal circuit. According to the principle, before the motherboard is powered on, we need to check value of these inductors. Prevent the component from being burned out by the short circuit. No matter what kind of motherboard is, we must have diode value for each inductor before powering on. Prevent short circuit. Once there is a short circuit, first repair it normally and then power on. This is a matter of principle in electricity. Regarding the equipment on this interface, we also need to check the value in maintenance. The device on this interface needs to open bin map for checking value. Measure again the bin map. This inductor don't need to be measured against the bin map. This is the time to repair a Mac. If screen line interface cannot be used, the value of the side screen line interface is required. If the keyboard interface cannot be used, test the value of the keyboard interface. We need to repair accordingly. The value of the pairs like this interface should be measured by opening the bin map. This is actual measurement method of the resistance value. If the keyboard interface is not available, measure the diode value of the keyboard interface. Measure the diode value of the hard disk when the hard disk is unavailable. Okay, take a look. This is Apple Mac bin map. The red represents positive pole, and this gray represents negative pole, which is a ground wire. When we check in the resistance value, we put the red pen on any of the gray points, the wire to ground, and black multimeter pen is placed on the red dot. You can see whether our circuit is short-circuited or open-circuited by looking at the value displayed on the multimeter. Take a look. If we click on any red dot, multiple red dots will come out at the same time. If you click on one, there are many places with the same color. It means that it is connected. In the maintenance, as long as I check the resistance value when there is a short circuit or an open circuit, it shows that some of the connected components has been damaged, and we need to test it further. Use a multimeter to measure which component is causing the open circuit and the short circuit. The diode value to the ground in maintenance, that is, the diode value is also very important. It is also necessary to know, this must be remembered, which line we repair and the diode value of which line should be used. Later we will talk about this kind of diode value in every circuit. First of all, we must distinguish its positive pole and the negative pole, and we must distinguish them. You can zoom in and see, GND is the negative pole. Put the red pen on any negative pole and do not move. The black pen is placed on the red pin we measure. Do you want to know the diode value of which circuit line? Put the red multimeter pen on the red pin you want to check. What is the setting displayed by the multimeter? If it is a few hundred, it is a normal circuit. If it is a 000, it is a short circuit. Then if OL appears, it means infinity. Then it is an open circuit. Short circuit and open circuit. Then we must find the components connected to the middle. This is called the diode value checking. Then get it to the board and measure it to everyone. Everyone look at our table. If two multimeter pens are connected to 0.002, it means a short circuit. This is an error of the multimeter. When we are measuring, if the diode value shows this state, it is a short circuit state. On the bin map, I suppose we see this interface. This is a display interface. The blue part is positive pole and the gray part is negative pole. If my screen is not bright, it doesn't display. At this time, we have to check the diode value of the blue part. What we want to measure is the value of the interface corresponding to the fault. If this interface is our display interface, if display does not show in the maintenance, excluding the display at this time is good, then we have to open the bin map to measure the diode value of these blue points on the display base. Measure again the drawing. So if you measure it now, look at one of the blue pin. Look at this pin. Let's look at the first pin. The red multimeter pad is grounded and the black multimeter pad is placed on the blue test point. Look at the 0.626. At this time, it belongs to the normal circuit state. If you measure that it is OL, it means that it is open circuit. If the display is 0.01 or 0.02, it is a short circuit phenomenon. Look for the circuit light. Then let's look at the second pin. 0.659 and 0.662, this is also a normal phenomenon. In the actual maintenance, we only need to measure the diode value of the blue pin. Gray pin don't need to be measured. By analogy, we have to measure the blue parts in the maintenance. As same as other interface, include USB port can be used, just measure the diode value of it. The keyboard port cannot be used, measure the diode value of it. To open the bin map to correspond measurement. Let's set another example. If it's still the screen interface, this 4 pin is grounded. Let's take a look at how much value we measure this. 0.02 is a ground-to-ground phenomenon. This is the value of 2 pans, which is the value of grounding. Just this 4 pin is also grounded, GND. GND is this value. Measure the pin below here and measure one on the bottom. This is blue. We measure the third pin. It has value. If we measure this, we have said that these yellow dots are connected dots. They are on the same circuit line. Then if we measure this point, the value is OL. It proves that there is still disconnection between these dots. We find out if it is a 0.01 short circuit phenomenon. It means that there is a short circuit state on the component with yellow dots. We need to find this short circuited component. This is how to check diode value to ground. How to repair it. Next, we will show you how to fix short circuits and open circuits. Okay, we just judge short circuit and open circuit through actual measurement. Let's talk about the analysis of this short circuit and open circuit, how to show the cause of the fault. First, talk about the cause of the short circuit. Generally, they are connected in actual maintenance, and the ground capacitor will cause. In the ordinary way, we first deduct the grounding capacitor first, prevent it from breaking down and causing a short circuit. If you eliminate the capacitor or short circuit, generally exclude connected ICs at this time. It can be said that 80% and 90% of the short circuits are caused by this reason. Then let's talk about it separately. If there are kinetic resistor and inductor, it will not cause a short circuit. Emphasize the point here. Then the reason for the open circuit is just the opposite of it. Generally, first look at whether there are adjacent resistor or inductor. If there is, I will eliminate it first. If not, there may be an open circuit inside the connected IC. That direct replacement. If the replacement is not good, that board layer is broken. PCB layer is broken. We have to make a jumper to solve it. This is how to show the two causes of the open circuit and short circuit. We need to know, and one more point. There are several special treatments for the short circuit. If the number of connected capacitor and the IC is relatively small, I will first eliminate the capacitor and remove them. If it is still not good, we replace IC at this time. On the other hand, if it is said that there are more capacitors and IC connected to it in maintenance, at this time, generally we use the burn-in method. Add resin cover the board to return it, and use the burn-in method to eliminate it. This method is quick and convenient. This kind of burn-in method is only to deal with the short circuit. Open circuit does not need to flash in to deal with. This is a solution for short circuit and open circuit. We just need to exclude them from the bin map. In the actual maintenance map, what do we often do? For laptops that cannot be turned on, priority should be given to check the diode value of the major inductors. Is there any short circuit between the inductor on our laptop circuit board? Generally, we must eliminate short circuits in our habitual actions. Then these inductors are being repaired, we have to measure the diode value of the circuit line where they are located. As long as a short circuit, if it causes our laptop not boot, if there is a short circuit, we must first check. So what are the large inductors in the Mac? The lines with large inductors are on the MacBook. What are our most common circuit lines? There is often a large inductor of 3V, 5V standby here. There are also our large charging inductors, bridge power supply large inductor, and memory power supply large inductors. There are also large inductors for independent display power supply and large inductor for CPU power supply. On one Mac, the common inductor circuit may insist this field. As long as there is a short circuit of any inductor circuit here, Mac won't turn on. Before powering on, we have to measure this inductor one by one. Don't miss out, check them one by one. Then if it found that as long as there is a short circuit of inductor circuit line here, it won't turn on. From the point of view of power connection, there are not many open circuits in this inductor circuit. Most of them are not booted due to the short circuits. Then we must check the diode value of this inductor circuit before repairing the machine. This point must be clear. So if one of the inductor was found to be short-circuited, how should we troubleshoot it? This is the most critical. So how to troubleshoot? Let's go. This concept must be remembered. At first, there is a large square-shaped inductor. We will measure whether there is a short circuit. If there is a short circuit, how we repair it? This is the most critical. Now let's talk about the repair method of the short circuit of the large inductor circuit. So we have to remember that this inductor is also mentioned in the previous lesson. When talking about the AP modes, it also mentioned related circuits. But I didn't teach you to measure. When we are checking, we also need to review the content of the previous lesson. So everyone knows that upper and lower tube circuit has an AP IC, and they are responsible for it. This is a lower tube, this is a PWM IC. This is G pole, this is D pole, this is S pole. This is the upper tube, this is a lower tube. When we talked about the MOSFET, we also mentioned that the large inductor. That is our energy storage inductor, then there will be a capacitor in later. Later is our low IC. Then we check the diode value. If the inductor is short circuit after checking, how should we troubleshoot it? This is our key point. In maintenance, we will not only check for failures, but also failures. This is the most critical. So here we have to divide it into two. This L is large inductor. If an inductor was measured to be 0, it is said to be short-circuited. Then how to troubleshoot? We have two poles in maintenance. Divide the two ends of the inductor into two. We call this end of the inductor the front end. We call the other end of the inductor the back end. We have to distinguish between the front and the back. There is no distinction, just use the drawing to justify. The end near the most is called the front end. Close to this end of the inductor, we have to prevent pin of the inductor before repairing it. Look at the front end open circuit or the back end open circuit. This kind of inductor repair method is generally used to pry the inductor into front end and back end. Then check the diode value. Then the inductor pry a pin. The end near the most is the front end, and then check the resistance value. What is the problem if the front end is open circuit? Generally, either the lower tube is broken or the IC is broken. Test the lower tube first. If there is no problem with the lower tube, then there is a problem with the PWM IC. That is to say, only one PWM IC and one lower tube at the front end will cause it to be short circuit. Generally speaking, I pry the inductor with one pin and measure the front end again. If it is short circuited, test the lower tube first and then difficult. If the tube is good, then the PWM IC is broken. Each of its inductors had corresponding upper and lower tubes and corresponding PWM power supply ICs. If checking the value, the front end is normal and not short-circuited, but short-circuited for the back end. That is a capacitor or the load repaired by the burning method. If it is short-circuited back end, first remove the capacitor next to it will break down. It won't cause the front, but you must pry the wires away. You can judge a problem if you don't pry open. In this case, if the back end is short-circuited, remove the kinetic capacitor first. It is possible that the certain capacitor has broken down, causing it to be short-circuited. If the capacitors are removed, there are tantalum capacitors beside these inductors, including non-polar capacitor. Each of them may be broken down, resulting in a short circuit. If I remove the capacitor, it is still short-circuited. At this time, the load on its back end is usually the BJ IC is broken. This IC is not the previous IC. Generally, either a graphics card or a bridge. Such ICs are broken, all BJ ICs are broken. It can be said that the probability of 80% is that the BJ ICs are broken. This is an elimination method of the inductor short circuit repair. The first step is to distinguish the front end and the back end theoretically. After distinguishing them clearly, check the diode value of the front end and the back end. First determine whether the inductor is short-circuited and whether the circuit line is short-circuited. Then distinguish whether there is a short circuit between the front end and the back end. Is the front end short-circuited or the back end short-circuited? This is our focus. Look at the drawing. If we measure this inductor L7200, its diode value is 0. There are 2 more poles. Let's take a look. This pole of the joint is 1 pole. When you click it, the 8 pins most connected to it. From then on, it is determined that this one is called the front end, which is an 8 pins MOSFET. In other words, this is a combination of the upper and lower tubes. You can see that when opening the schematic, its upper and lower tubes on the schematic diagram are combined. Of course, if the front end is short-circuited, we apply the inductor array. First take down the MOSFET first. If it is still short-circuited after removal, it is not a problem with the MOSFET. If the diode value is checked after the removal, it will not be short-circuited. This tool has been damaged, so how to find this IC? According to the principle we talked about in the last class, the short circuit of the front end of the inductor is caused by the damage of the lower tube. Because this tube doesn't fit, so we directly exclude this tube. Then if the lower tube is not damaged, at this time we follow the 5th pin of the IC to find the IC. Let's zoom in and see. This DRVL pin is connected to the IC. Click it to find which power supply IC is the connected IC. Let's find the power supply IC again. Let's take a look at this. Then we have to replace this IC. That is to say, the cause of the front end short-circuited is either the power supply IC or the lower tube. So this point must be clear. What if the back end is short-circuited? Let's look at the back end again and then turn on the same inductor. Later, this inductor won't be connected to the MOS. Let's take a look. Not connected to the MOS. Further determine that this inductor pin is the back end. It connects more capacitors on the drawing. Many capacitors. C is capacitors. We can zoom out. Because there is a lot of current here, we can only power up and burn the Mac. How much volt to add? Because of the inductor of this circuit, it was 5 volts just now. We will adjust to 5 volt, then touch the capacitors. Is there any heat? If I find one that is hot, I will deduct it and not install it. If all the capacitors don't heat up, let's take a look at which IC we'll connect later. We find this jumper. The other end of the jumper, here is the jumper. Click it again. Zoom out, let's see which IC it is. Okay, let's take a look. If the back end inductor is short-circuited, we apply the inductor. Let's take a look at the back end with more capacitors. Let's rule out whether there is any problem with these capacitors. Use the burn-in method as much as possible. You see which IC are connected to the back end. Let's zoom out and look at the IC connected to the rear pole. Look at this position. Use 6A00, including these capacitors are possible. Looking down again, there is this position. You can see the yellow part from the picture. There are many short-circuit components, so we can only use a burn-in method. If the back end is short-circuited, use an ammeter to add voltage to 5 volt. Touch the yellow part to see which capacitor or IC is damaged. Replace it. But if the capacitor is broken, it can be deducted and not installed. If the IC at this back end is broken, you can only find a new one to replace it. This is a way to deal with the short circuit of the back end. Then let's take a look at the circuit where the inductor is located on the schematic diagram. Let's look at the page 63. Everyone, take a look at the inductor we just measured. This inductor is short-circuited. We call this end of MOS the front end. The front end contains this lower tube. The lower tube is grounded. The upper and lower tubes of the motherboard are combined together. We say that the front end is short-circuited. First, troubleshoot this Q7220. If this MOS is removed and it is not short-circuited, it means that the mode is broken. If you remove the mode without checking the diode value, the front end is still short-circuited. Look at the third pin TG of this IC, which is connected to the IC. Let's move over to C. Just followed by the power supply IC U7201. At this time, we can troubleshoot this IC. That is to say, the only cause of the short circuit of this front end is the lower tube. Because the upper and lower tubes of the MOSFET are combined, we just exclude it. If the short circuit remains after removing, directly to find the IC. The short circuit of front end is simpler. However, due to the short circuit of the back end, its inductor involves more capacitor and ICs. We can also see from the bin map that there are more yellow parts. There can only be a burn-in method to add voltage of 5 volt to it. Because it has been marked on the drawing, it is 5 volt. Then the power supply is adjusted to 5 volt. Regarding the yellow part of the bin map, you can deal with whichever heating you touch. Don't install the heating capacitor directly and replace the heating IC directly. This is how to repair short circuit of the large inductor. So in the maintenance, we can see from the bin map. If the line of the interface is short-circuited, a pin is short-circuited. It is also through the bin map, right? Generally speaking, we open the bin map. If it is short-circuited, generally there are not many components connected to this pin. Generally speaking, what is the pin directly connected to it? Either the capacitor can first deduct the yellow part. If there are more capacitors, use a burn-in method in the same way. Most of the capacitors are relatively small, unlike the circuit with large inductor. The backend has more capacitors. The circuit of the interface has relatively few capacitors connected to it. If you remove the capacitor, it still doesn't work, then just replace the IC connected to it. If there is an open circuit, it won't be a capacitor. Either it is resistor or inductor or IC, or it is disconnected. O.O is short-circuited. OL is infinity, also called open circuit. How to show the value displayed by the multimeter? So if we open the bin map, like the USB port, fan, screen interface on computer. There is also our keyboard port, which is often unusable. We want to check the corresponding position to the bin map and check the positive pole value. Repair the circuit of which pin is short-circuited and open circuit, and troubleshoot it. This is how to repair the interface short circuit and open circuit. Okay, if we have an interface that cannot be used, assume the keyboard interface of the MacBook, this is solder pin below it. If your keyboard doesn't work, I change keyboard, but still the same. At this time, we have to buckle the keyboard and check the diode value of the blue pin of the interface. Found that the certain pin is abnormal. Take a look if the diode value of this pin shows open circuit. When you click on it, what do you think it is connected to? There is no component connected to it, and it is directly connected to the inside of the ECIC. That is to say whether it is open circuit or short circuit. Because there is no resistor, capacitor, inductors, and other small parts in the middle. Just change the IC when you troubleshoot them. After replacing IC, but still open circuit, I make jumper directly from this pin to this pin we just tested. These two pins come on the jumper. When it is open circuit, change the IC directly if it is short-circuited, because there is no capacitor connected in the middle and no other components are connected. Relatively speaking, this is a bit simpler, but we can be lazy when checking resistance value. Suppose I measure another pin to check again. Feel free to take a pin. Look, it is connected directly to the IC and nothing is connected in between. That causes the interface of the device cannot be used. Either the socket is broken or the IC is broken. There is no other reason. This is an interface, including USB port, as well as the fan interface and the screen interface. We use the same principles and method to detect. Be sure to distinguish the positive pole and the negative pole of the interface. This is a repair method of the diode value of the interface. Let's take a look at this interface, its resistance value. When we are checking the diode value, it is measured to be 0, 0. That means there is a short circuit. Let's see that there are a lot of capacitor connected to it, and the yellow part is on the top. These are all in its power supply. At this time, to cause short circuit, we can only use a burn-in method to burn the laptop. For 3.3V open circuit, if OL open circuit, the multimeter may be placed at this point. See if the capacitor next to which IC is connected or not, and see if it is not connected. If it is OL, it means that it is open, which means that the connection between them is disconnected. To measure IC one by one, if there is no connection with a capacitor, it will be disconnected. If it is connected, look at the capacitor and the bottom of the IC again to see if they are going to work. If it doesn't work, you can make jumper to connect it, other IC, and so on. Also use the same method. If it is another IC, it will have a capacitor next to it. Let's take a look. Put one end of the multimeter on the interface and the other on the seam. If they are OL, it means that they are disconnected. Just make a jumper to this interface from this point. If the two are connected, there may be a disconnection between the two. At this time, short circuit these two pins, we call short circuit. Each IC is proceeding this way. The open circuit is through the firing line, because there are no related big components. Current does not cause an open circuit. It can only be an IC or resistor or broken wire. Which IC is disconnected from this? We can only use a multimeter between the capacitor and the interface next to it to measure whether it is a OL state. Put one end here and not move. The other multimeter pan is placed on the component next to the IC. Relatively speaking, there are not so many open circuits in actual maintenance. Most of them are short-circuited a little more. The open circuit is relatively more open usage. It is a laptop that has been water damaged or it has been dropped. Signals like this must be tested. If 1.5V is short-circuited, we will use a 1.5 to burn. This is how this interface shows their diode value. In the maintenance, which interface is abnormal? Measure the diode value of this interface. How to solve the short circuit? How to solve the problem? Other interfaces are also excluded in the same way. This can be too troublesome. They are both with the processing method of the interface. This class comes here first.